Hi everyone, I'm Yogadharani, working as Assistant Professor, Department of Computer Science and Engineering at SNS College of Technology. Today we are going to learn about important topic from model evaluation to precision recall curve. So before learning the precision recall curve, we should already understand some basic concepts such as classification, confusion matrix, true positive, true negative, false negative, and then classification matrices. Today we will understand what is precision, what is recall, why do we need both, then what is the precision recall curve, how does the curve helps us select a suitable classification method. So this slides recalls classification, confusion matrix, true positive, true negative, false positive, and false negative. Before starting precision and recall, let us quick revise the confusion matrix. Yeah, classification matrices predicts whether something belong to a particular class. For example, suppose we are building a model to detect spam emails. That model predicts spam, not spam, likewise. So now we compare the prediction with the actual results. We have the four responsibilities like true positive, which means the model predicts spam as it is actually a spam. True negative means the model predicts not spam, but it is actually not spam. True negative. And then false positive means the model predicts spam, but it actually it's a not spam. And also like false negative means the model predicts not spam, but actually it is a spam. So mm, and today's understanding the scenario, imagine that you have develop a machine learning model to detect fraudulent bank transactions. Suppose the model identifies 100 transactions as fraud, but only 70 of those transactions are actually fraud. So, should we trust all 100 predictions? No. We need to know out of all the transactions predicted as fraud, how many were actually fraud. This is where prediction becomes important. Now imagine that there are actually 100 fraudulent transactions in the database. Our model identifies only 60 of them. So then we need to ask, out of the actual fraudulent transaction, how many did our model correct identify? This is called recall. So this is here comes becomes recall is more important here. In here, thus this slide shows the introduction of a define and empathy stage. Before moving to the ideation, let us think the perspective of a person who is affected by the prediction. Imagine if you are a bank customer, the fraud detection system should correctly identify the fraudulent transaction, but there are two different problems error. The problem one is too many false alarms. The system marks many genuine transactions as fraud. The customer may become frustrated. Here the precision is important. Missing actual fraud. The system fails to identify genuine fraudulent transaction. This is called a financial loss. Here recall is very important. So we need to identify our problem properly before selecting the evaluation matrices. Here suppose our classification model gives a probability example a transaction from up to 5 cases, and then probability that is a fraud probability also there. If we choose 0.5 as the threshold, transaction above 0.5 are classified as fraud. But what happens if we change the threshold to 0.7? Our prediction will change. Therefore, the changing the threshold changes precision and recall. So this is the basic idea behind the precision and recall curve. Here generally we change the classification threshold, precision and recall also changes. If we make the model more very strict about predicting positive cases, Positive may increases because we are predicting only the positive when we are highly confident. Therefore, recall may decrease. If we make the model less strict, we may identify more actual positive cases. So, if recall may increases because we may also produce more possible positives. Here, precision may decrease. Here, small trick as precision means how correct are my positive predictions. Recall means how many actual positives did I found. And this shows the general process of uh, how a data set and then classify to the training classification model and then turns to the generate prediction score and then calculate the precision recall and then plot PR curve, that is a precision recall curve. And this shows a precision recall curve is a graph that shows the relationship between the precision and recall at different threshold classifications. The graph helps us understand how precision changes when recall changes. For example, if our threshold changes from 0.5 to 0.7, the number of positive prediction changes. As a result, precision and recall also changes. We plot these values to understand the model performance. Yeah, the purpose is to understand the precision recall trade-off, to select a suitable threshold, to evaluate the classification models useful for imbalance data sets, and then identify the whether a model is effectively at detecting positive cases. And this leads us the workflow of precision recall curves. And this was the applications where machine learning, real-time applications such as healthcare, uh, email, email detection, that is spam detection, information retrieval such as finding relevant document in a directory. In banking, there may fraud and transaction detection, in cyber security and in a computer vision. And this shows the knowledge map between the knowledge map of today's classes. So before we finish, let's a quick check our understanding. Today we show about what is precision, what is recall, what happens when we changes the classification threshold, what does precision recall curve show, where can we use precision recall analysis. Finally, precision tell us how correct our positive predictions are, while recall tell us how many of the actual positive cases we actually found. Thank you. Hope you understand today's class. Catch you in another video.